call is now being recorded.
मोबाइल से क्लास कर रहा हूँ, यहाँ मोबाइल से ऑडियो कर रहा हूँ, लॉगिन करके स्लाइड चेंज कर रहा हूँ, वही तो प्रॉब्लम हो रहा है। क्या रहता है आपके पास बता नहीं, वो देने में जरूरी चीज होगा, बार-बार बोलते जाए वो उसको जो पता है कि क्या करना है।
Okay, Vansika, so shall we start?
Yes, sir. Yes, sir.
Okay. So what we had discussed in earlier class, so from there I will begin. I had discussed with you all basic signals classification, if I am right. So
Yes, sir.
what I had discussed, signals. Is this screen visible?
Yes, sir. It's visible.
Okay. So in signals, we had seen we can basically, it may be classified into two ways, continuous time signal and second one digital signal. And further, continuous time signal is divided into two. That is first what we call continuous time signal and second discrete time signal. So here basically we have to focus over the discrete time signal. Discrete time signal. And also we will learn, although this is not a part of your syllabus, but I will focus. Also, we will deal here about continuous time signal. So in starting, I will go along with both continuous time signal as well as discrete time signal. And as lecture progress, so where I feel the continuous time signal is not necessary, there I will leave this portion and I will continue with discrete time signal. So in starting, I will consider both so that you could understand difference between these two. And from the gate examination point of view, both are very, very important. Even 80% of questions are from continuous time signal and 20% questions from discrete time signal. So that depends. If you are really preparing for gate examination, so in that case, you have to focus on both. But in our syllabus, we have to focus on this discrete time signal. Okay. So now here in discrete and continuous time signal, we see three basic elementary signals. First is basically unit impulse signal. This I have already discussed in earlier class in detail for both discrete and
Excuse me, sir. Sir, you are not audible.
the characteristic of these three in discrete as well as in continuous. Now, understanding these basic what we have classification of signals. So these three are the basic elements for continuous time as well as for discrete. And using these three, not using these three, only next we have to consider cosine and sine also. These two signals are also elementary signal, cosine and sine. So with the help of these 5, we can implement any kind of signal. That's why this comes under basic elementary signals. Basic elementary signals. I'll take one example and I'll show you how we can have any kind of signal with the help of these 5. That we'll discuss in tutorial class, don't worry. So going ahead, what we have next, classification of signals. So you all know definition of signal is basically it is a physical quantity which varies with respect to independent variables. So independent variables may be length, maybe distance, maybe time. So here we have to consider our signals, and independent variable will be time. So time will be your independent variable in this course. And on the basis of this, now we are going to see the classification of signals. So signals classification. My next topic is signals classification. And this is important. So each we have to understand very carefully. Signals classification. So let me start with the classification. First classification will be under this that we call periodic versus aperiodic signal. Periodic versus aperiodic signal. So in both cases, you have to see how we can say signal is periodic or aperiodic or non-periodic signal. So definition for periodic signal, signal which repeat itself after certain time. Suppose, for example, this is my signal that you consider a shape of sine, and this is my signal shape. Suppose this way it goes. Consider this dependent variable x, and here independent variable time t, and this way it will go till infinity, minus infinity to plus infinity, this way. And you consider this is your time period. Time period means a period in which we have one complete full cycle. Next, what we have to t naught, and so on and so forth. So for this signal, we see after this time, this signal repeat itself. So this is called your time period, or we can call this fundamental time period. This is time period t naught. So if this time period is t naught, so people will ask you, okay, please let me know what is the frequency of this signal. So frequency of you studied in 10 plus 2, frequency is reciprocal of this time period. We say 1 upon t naught. So this is what we have, frequency signal. And same you consider for the case of this as well. Same, but here in discrete, this is your continuous time signal. Why this is continuous time signal? Because this signal has continuity in time as well as continuity in amplitudes. That's why this is called continuous time signal. So this is an example of continuous time signal. Continuous time signal. And same if you consider discrete, that will be discrete in time but continuity in amplitude. So that will be your discrete time signal. So for discrete time signal, if you consider example for this same continuous time signal, Shape would be remain same, but here you see this is your discrete in time and continuity in amplitude. We have continuous nature in amplitude. So this way it goes like this. So here you consider this is 0, this is 1, 2, 3, 4, 5, and so on and so forth. Suppose this is up to 10. So this is what you have, and this way it will go. After this, it will repeat itself. So we consider this 10 as a time period. And here my notation of this discrete time signal will be x as a function of n. And here independent variable will be a small n. So here I will say how many number of samples. So you consider here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Means if you have this 10 means 0 to 10 means you have number of sample n equal to 11. 0 to 10 means we have to consider 0 to 10 means number of sample would be 11. So this will be your time period, Vanshika. This is your fundamental period for the discrete time signal or sequence, we can say. So when you are going to say period, you have to use this notation, capital T for continuous time signal, and for discrete, you have to use capital N. This is for discrete. Now, on the basis of this, now how we are going to define periodic signal in mathematical form. So here I may write this way, a signal is periodic. This will be my statement. A signal is periodic when it satisfies the given condition. So what condition is? For the case of continuous time signal I am discussing here, xt plus t naught, that gives you xt, then this signal will be periodic. Xt plus t naught is fundamental period. And what does mean xt plus t naught? Means this signal is shifted by towards left, we can say. And if it is t minus t naught, that is towards right. So I will show you. I will take one example and I will show you how this function xt plus t naught, if xt is given to me, so what will be the waveform of xt plus t naught? I will show you in tutorial class. But for this time being, just you understand, if xt plus t naught, if this is equal to xt, then we can say that signal is periodic signal. Means after t naught signal repeat itself, that signal is periodic signal. So this is for continuous, and same for this discrete. A signal will be periodic if x of n plus capital .
Excuse me, sir. Sir, you are not audible.
This will be your fundamental period, capital N, fundamental or time period, you can say. Okay, so now question may ask, if this is continuous time signal and this is discrete time signal, and both are periodic. This is the assumption that by somehow we got to know that this signal is a periodic signal. Now question may ask, sir, if this signal is periodic, please let me know what is fundamental period. How do we find the periodicity of the signals? So this is what we are interested in. Now question is very important. How to find fundamental period? If signal is periodic, how to find fundamental period? That is a question, and that we have to see what would be a solution for this uh, in detail, right? Okay.
Yes.
So here to find fundamental period, see what we can write. So to find fundamental period, what we have a condition to find fundamental period for both student. I am saying for continuous as well as discrete. To find fundamental period, what should we do? That is a question, and answer for this here. Okay, consider same. Suppose this is my sine wave, okay, and you consider this magnitude is +1 and this is -1. So what I can write in mathematical form, xt will be sine omega naught. Omega naught means 2 pi f naught, omega naught t, and assume some phase angle. There is some phase. So here magnitude is 1, so you mark here 1. This 1 is amplitude, sine omega is frequency, and this omega is basically 2 pi f naught, and this f naught is frequency, and in time period that is 2 pi upon t naught. So this way you can write 2 pi upon t naught. Okay, so this signal is not periodic. So now when we call this signal is periodic, once we satisfy this condition. So RHS we got xt equal to this. So from LHS what I may write? So from LHS what you have to do, simply replace t with t plus t naught. So wherever you have t, that t will be replaced with t plus t naught. This is omega naught t plus t naught plus phi. Perfect. So now we see this is the condition of periodicity. If this is the condition of periodicity, means xt plus t naught should must be equal to xt, means LHS should must be equal. If LHS equal, then RHS should must be equal. So when RHS will be equal, see here, we got here sine omega naught t plus phi, and from this we got further, if you simplify this, that gives you omega naught t plus omega naught t naught plus phi. So if you compare these two equations, suppose this equation number A and this equation number B. So when you say these equation A and this equation A and B equal, see here, if you compare right hand side of equation A and B, this is your sine, this is perfect matching, omega naught perfect matching, t perfect matching, phi perfect matching. Only you have a difference of this omega naught t naught. You don't see omega naught t naught in equation A, but you have omega naught t naught. This is your extra term present in equation B. So if we make an effort so that by putting that value in place of this omega naught t naught, that equation.
Sir, you're not audible. Excuse me, sir. Sir, you're not audible.
Am I audible, Vanshika?
Yes, sir. Now you're audible.
Okay. So equation A and B will be equal. When it will be equal, now see here. When equation A and B will be equal. Condition when omega naught T naught equal to 2 pi into m. M is your integer number. Means 2 pi will be multiple of m, where m is integer. M equal 1, 2, 3, 4, 5, and so on and so forth. Means, see here, if you have sine 2 pi plus theta, that gives you what? Sine theta. Sine 4 pi plus theta, that gives you sine theta. Sine 6 pi plus theta, that gives you sine theta. So if I assume this omega naught into T naught, that is equal to 2 pi into m. So 2 pi into m plus omega naught T plus phi, that gives you what? That gives you simply sine omega naught T plus phi. Is it okay, Vanshika? Understand this point?
Sir, please explain one more time this one.
Okay. What I'm saying, when I can say equation A and B will be equal. See here, equation A and B will be equal only when omega naught T naught, in place of this if I keep 2 pi. In place of this if I keep 2 pi, then you see sine 2 pi plus theta. So assume this omega naught T plus phi as a theta. So 2 pi plus this combination gives you what? Simply it gives you sine 2 pi. This is what this way I will write. Sine 2 pi plus omega naught T plus phi. And this you assume as a new quantity. You say phi. Sine 2 pi plus phi, that gives you what? Sine phi. So phi is what? Omega naught T plus phi. That is sine omega naught T plus phi. And this is exactly same what we have written in equation A. So equation A and B will be equal when we have omega naught T naught, that is equal to 2 pi multiple of integer number m. M may be 1, maybe 2, maybe 3. So if it is 2, means that will be 4 pi. So sine 4 pi plus theta is what? Sine theta. That gives you same value. If m equal to 3, that gives you 6 pi. 6 pi plus theta, that gives you sine theta. So when we have this condition, then we can say equation A and B are equal. Understand?
Yes, sir.
Okay. So this is a condition. So at this condition, we can say equation A and B will be equal. So if this is the condition, what we can write now hereafter, omega naught into T naught, this is equal to 2 pi m. M, remember this m is integer number. Where m is integer number, don't consider decimal value. M is integer number. Therefore, what is fundamental period? That is T naught equal to pi m upon omega naught. So this way you can find fundamental period, student, for continuous time signal. Remember this is for continuous time signal. Whatever we have deal, this is for continuous time signal. So T naught is 2 pi m upon omega naught. So this is for continuous time signal. Whenever you have to find fundamental period, you consider this equation. Now, in the same way, to find fundamental period for the case of discrete time signal, how you proceed? Same way you consider this. In place of t, in place of t, what you will assume? Small n. So wherever you have t, you consider small n, rest parameters would remain same. So what will be my assumption now here in place of capital T naught? What is a notation? We have to use this notation capital N. So here you have to use in place of capital T naught, you have to use capital N. So what condition will be? So condition will be omega naught into n, that is equal to 2 pi m. That's very simple. And when we have this, so what is now fundamental period for discrete time signal? N will be equal to 2 pi m upon omega naught. Then you will answer both are same. If you consider RHS part here, this is 2 pi m upon omega naught. This is 2 pi m upon omega naught. So why do we have these two different equation? Is it necessary to write this way? Or simply we can say that T naught equal to n. So whatever the fundamental period for continuous time signal, that will be a fundamental period for the discrete time signal. No, we cannot say. Although this equation looks like same, but please don't consider this. At this moment, I told you fundamental period this way you have to compute, and for the case of discrete time signal, you find fundamental period this way. So this is what we have. Once we have this understanding, then we'll discuss problem, and from this numerical problem, I'll make you clear this T naught may not be, this T naught will not be equal to capital N. So that depends on frequency. So that depends on frequency. So frequency will be differ. So once we discuss problem, and there it will be more clear to you. So at this moment, just you know how to find fundamental period theoretically. So this T naught equal to 2 pi m upon omega naught, and equal to 2 pi m upon omega naught. So this is what we have. This is what you keep so far. Any confusion, Vanshika, please let me know. In this basic for both continuous time signal and for discrete time signal.
No, sir, it's clear.
Perfect. So now next, once we have this basic understanding of periodic versus non-periodic or periodic signal, next second we are going to discuss causal versus non-causal signal. Second classification, causal versus non-causal, and this is very simple. And same definition you can apply for continuous as well as for discrete. So B, causal versus non-causal. Causal versus non-causal. Non-causal signal. Yes. So statement for causal signal, a signal is said to be as causal. A signal is said to be causal when see here, whatever the case, continuous time or discrete. Let me consider continuous time. When xt equal to 0 when t negative. Remember, or other way to say, xt will give you non-zero value, non-zero when t positive. What does mean? Means if you consider this as example, if you consider this as example, this is my sine wave. We have only one side of this signal, that is positive side of this independent variable t, and there is no magnitude in the negative side of this independent variable. Means we have magnitude complete 0. So what we can say, so I can say about this signal xt, this is your xt, xt equal to, consider this a magnitude +1, and consider this -1. So xt equal to sine, you consider here time period t naught. All this is not periodic signal, student, but consider this as a t naught. So this signal is not periodic. Why this is not periodic? Because you see here, this side we don't have any repetition of this shape. This shape is not repeating when time is negative. So this signal is not periodic. So mathematically, how we are going to write that, I'm going to tell you. So this is sine omega naught t naught. Also consider some phase. So this, I will say, this will be xt equal to sine omega naught t naught plus 5 when time t is positive. When time is t greater than 0, then we see this sine omega naught t naught plus 5. But when time t lesser than 0, we don't see any sinusoidal waveform. Instead, we got 0. Instead, we see 0 magnitude. So we say xt equal to 0 for time t lesser than 0. So this is your causal signal, Vanshika. This is your causal signal. Why this is causal? Because xt equal to 0 for time negative and xt equal to non-zero for time positive. So this is your causal signal. This waveform is basically your causal signal. This mathematical equation, while seeing this, we can say this is my causal signal. So this is a statement of causal signal, whether it is continuous or discrete. This is for continuous, and for discrete, what you can write? For discrete, simply you will write xn equal to 0 when n is lesser than 0. And this is finite, or we can say non-zero, or we can call non-zero when n greater than equal to 0. For example, you may consider this. For example, you may consider this signal. Suppose we have a unit step. N equal to 0, we have magnitude 1. N equal to 1, we have magnitude 1. N equal to 2, we have magnitude 1, and so on and so forth. This way it will go up to infinity. So this is n equal to 0. This is n equal to 1, 2, 3, and so on and so forth up to infinity. And for n negative, means n equal to -1, magnitude 0. I'm sorry, I'm using word magnitude. It should be amplitude. N equal to -2, amplitude 0. N equal to -3, amplitude 0. So this way it goes up to minus infinity. So minus infinity to plus infinity, you see that this is satisfying this condition. When time negative, we see there is no there is an amplitude that has a value 0, and this is xn that has a non-zero, means magnitude amplitude is non-zero when time n is greater than equal to 0. So this is also your causal signal. This is also your causal signal. Now you may ask, sir, then please let me know the example of non-causal signal. So simple example is once we have this kind of information like this. Suppose it is started from here, 1, 0, this. So you see here, xn equal to 0, this is perfect, but what we have a condition lesser than -1. But at n equal to -1, we have non-zero. So this is not a causal signal. So in this case, you can say this is a non-causal signal. When we have for time negative, if we see any non-zero sample, then while seeing that, we can say that signal is non-causal. In the same way, if you see here, this signal, suppose we have this kind of shape, something like that. And then after this, we have a 0. Then while seeing this portion for this negative range of this time, we have some non-zero magnitude. So we can say that signal is a non-causal signal. So simple as a statement for causal signal for time negative. If amplitude of that particular variable is 0, then we say that signal is causal, otherwise non-causal. Hope I clear to you, Vanshika.
Yes, sir. Yes,
Okay,
sir. It's clear.
perfect. And next, what you have third classification that I may consider here, which is very, very important, and many times questions were asked in gate examination related to symmetric versus non-symmetric signal, symmetric versus third classification I may consider symmetric versus non-symmetric signal. Non-symmetric signal. Also, this is called symmetric signal is also called even signal, and non-symmetric signal is called odd signal. So this portion I will continue in next class because this is very, very important, and I want this to discuss with you as well as with student. क्या नाम है उनका? भूल गया मैं.
Sir,
वंशिका,
Anuradha.
अनुराधा, हाँ हाँ. तो वो भी रहेंगी, तो हम साथ में डिस्कस करेंगे. और ये टॉपिक थोड़ा सा इम्पोर्टेंट है और कॉन्सेप्चुअल है. So I wanted to discuss this when she will be here in online class, right?
Right.
So
Yes.
एक बार थोड़ा सा आप रिवाइज कर लीजिएगा जो भी मैंने प्रीवियस क्लास में पढ़ाया है और आज क्लास में पढ़ाया है, and
Yes,
then
sir.
I will maintain our continuity, right? Okay,
Okay,
so
sir. Okay.
next class will be on symmetric versus non-symmetric signal.
Okay, sir.
Thank you, Vanshika.
Thank you, sir.